You are provided with a suitable measuring instruments and a piece of light string to determine the density of the material of a metal ball whose mass is in the order of 100 grams. It is not the correct value. It is an approximate value. The metal ball has a hook of the same material permanently attached to it. Part A. If you have access to a set of spring balance having masses of 75 gram, 150 grams, 200 grams and 500 grams. Which one would you select for the measurement? Give the main reason for your selection. They have given the approximate mass of the given metal ball is 100 grams. We can't measure that mass by using given first spring balance because of its maximum readable mass is 75 grams. Therefore, we can't get it. We can't use 200 grams and 300 grams spin balance because of when the range of the measuring instrument increases, there is a low accuracy. Therefore, we can use the 150 grams spin balance to obtain the given mass, to measure the given mass. Then we can write 150 grams mass spin balance. Then we have to write the reason. We can write the reason. We can measure the mass of Bob with a high accuracy. We can use high accuracy or we can use high sensitivity. There is a high sensitivity for the measuring instrument with the low with the measurement range of measurement is a small value. In part B, a student performing this experiment obtain following measurements correctly for the diameter of the ball. State the reason why the readings are different. They have given that all readings are correct readings, but there are different values. We have to explain the reason for different of values. We can write the reason for the different values. Metal ball is not exactly spherical. Metal ball is not exactly spherical. We know that when measuring diameter, we are using diameter in this direction, this direction, this direction, like this. We have to use different directions. When getting different directions, they have obtained different values. Therefore, we can consider that this sphere is not a uniform one. It means it is not exactly spherical. Then part C, indicate the measuring instrument he may have used assuming that the selected a suitable instrument for this purpose. They have obtained values up to 3 decimal places in centimeters. If we are considering first reading, it is this one in centimeters. if you are converting to this one to millimeters, we can multiply it by 10. Then we can obtain 35.23 millimeters. Therefore, we can obtain up to second decimal place in millimeter. It means this instrument should be micrometer screw gauge. When considering instrument, we have to consider the size of the measurement. It is about 3 centimeters, 3.5 values. Therefore, we can obtain 3.5 values by using the micrometer screw gauge. But if they have given a value like this, we can't get this reading by using micrometer screw gauge, because of this reading is greater than maximum reading of micrometer screw gauge. Now we can use micrometer screw gauge. Then part D, considering the function of the above reading, suggested another measuring instrument with a different accuracy that can also to be used to obtain the diameter of the ball. Give the reason for your choice. We can obtain the diameter of the ball by using vernier caliper. Now, least count of vernier caliper is 0.1 millimeter. Therefore, there is a different accuracy than micrometer screw gauge. They have asked the reason for your choice. We can obtain the diameter by using external jaws. You see, it is easy to get. If you are using an instrument like traveling microscope, it is difficult to obtain the diameter, because of we have to focus traveling microscope correctly to this point and this point. Therefore, if you are using micrometer screw gauge, there is a high accuracy of the measurement, because of we can obtain up to 0.01 millimeters. But if we have to select another instrument, vernier caliper is the suitable one, because of we can obtain diameter, we can measure diameter easily than other instruments. If the mass of the ball with the hook is m and diameter of the ball is d, write down an expression for the density. Assuming that mass of the hook is m over 50. We can get, again, we have to write mass, an expression for the density. Density equals to mass divided by volume. But now they have given, there is a hook with the given sphere like this. It is attached permanently with the sphere. Therefore, we can't get mass reading without the hook. Therefore, capital simple M mass is the sphere, mass of sphere with hook. We have to subtract mass of hook. It is given as m over 50. This one is total mass, this one is mass of hook. Then we can obtain difference of two given values, m and m over 50 is the mass of sphere. Then we have to divide it by volume of the sphere. They have given diameter. We can substitute volume of a sphere 4/3 phi r cube. R means radius. Now they have given diameter. We can divide diameter by 2 to get the radius to the power 3. We can simplify it, but it is not compulsory. We can get this one as the answer for part E. Part F. If a suitable measuring cylinder and water are provided, indicate major steps of an alternative method which give the volume of the ball. We can get measuring cylinder and we have to fill water to a suitable level. Get measuring cylinder and fill water to a suitable level. Then second one, note down the reading of water level. Third one, immerse the ball in water. Third, and then we can obtain fourth step, get the reading of final water level. I will write it. Immerse the ball in water. The last step, get the reading corresponding to new water level. Finally, we can write volume equals to difference of readings. Difference of readings obtained corresponding to water levels. In part G, if the scale of the measuring cylinder can be read with sufficient accuracy, write down two advantages in method in F over the method indicated in B. Yes, we can obtain volume of sphere with a high accuracy by using the method described in F. It means immersed in water method. Because of, if the sphere is non-uniform, we can't calculate by using this equation its volume correctly. We can get an approximate value, but it is not correct. Then we can get, if the sphere is non-uniform, we can obtain volume correctly. Then we can get another one. We can immerse hook in water. We can immerse hook in water. Then displaced water volume is equal to volume of sphere and hook. Therefore, we can get total mass for the mass of the object, and we can substitute displaced water volume because of displaced water volume is equal to volume of sphere and volume of hook. Therefore, there is no an error due to the hook.